Hey you guys, this is Mr. Millings, and in this video we are going to learn about the rules of rounding in chemistry. And before we start talking about how we're going to round our calculations and answers and measurements in chemistry, here's a little disclaimer. It says that prior knowledge of the topics below is essential before watching this video. So I recommend that you have already watched the video on significant figures and the video on scientific notation before watching this video on rounding. So let's jump right in and start talking about significant figures first. So if you remember from an earlier video, we learned how to count significant figures, and here are the rules right here when we're counting significant figures. And real quickly, let's just go ahead and apply these rules that we've learned in an earlier video to these numbers or quantities or measurements right here. If we wanted to know how many significant figures there are in this number, leading zeros never count, so none of these are going to count. They're just placeholders. However, all of these are going to count because they are non-zero integers. So this number right here has a total of 5 significant figures. If we take a look at this one right here and we start on the left-hand side of our little number here, we have a non-zero integer followed by trailing zeros, and in the rules to the left over here it says that trailing zeros are significant only when there is a decimal in the number. So because there is no decimal in the number, these are just merely placeholders, and so there's only one significant figure in this number. If we take a look at this number right here, we'll start all the way on the left. The 1 is significant, the captive 0 is significant, the 5 is significant, but the trailing zeros here are not significant because there is no decimal in the number, so there's 3 significant figures. If we take a look at this number right here and start all the way on the left, the 2 is significant, the 3 is significant, the captive zeros are significant, the 3 is significant, the 4 is significant, and this trailing 0 right here is significant because there's a decimal in the number. So if we count these up, we have 1, 2, 3, 4, 5, 6, 7, 8 significant figures in this number right here. If we take a look at this one right here and start all the way on the left, all of these are not significant. The leading zeros here are not going to be significant. Leading zeros are never significant, as it says right here. The 5, the 2, the 4, the 3, the 1 are all significant, and last, this trailing 0 is significant because there's a decimal in the number. So there are 6 significant figures in this number right here. If we take a look right here at 400 students, this number right here was obtained by counting, and it says that numbers obtained from counting, or numbers that are part of a conversion factor, have unlimited sig figs. So this would be said to have an unlimited number of significant figures. All right, let's take a look at this one right here. Leading zeros are never significant, so leading zeros are never significant, and the only significant figure in this number would be this 1 right here. So there's 1 significant figure. So this is just a review of how to count significant figures. When you're trying to count how many significant figures there are in a number, make sure you always start off on the left-hand side of that number and work your way from left to right. All right, so now let's take a look at number places and sig figs and see how they kind of go together or play together when we're taking a look at a number. So let's take a look at this number right here. We have 12,306,462.19820 kilometers. And so on the bottom here, what we're looking at are the places, the place values of each number that is in this really big number right here. And on the top, we have the significant figures that we can count from left to right. For example, starting off on the left-hand side, we have our first significant figure right here, our second, our third, our fourth, our fifth, all the way till our 13th significant figure. But if we take a look at the bottom here, just a review from your math class earlier on in your academic career, let's go ahead and start right here at this 2. This 2 right here is occupying the ones place. The 6 is occupying the tens place. The 4 is occupying the hundreds place. The 6 is occupying the thousands place. The 0 is occupying the 10,000s place. The 3 is occupying the 100,000s place. The 2 here is occupying the millions place, and the 1 here is occupying the 10 millions place. And if we move to the right of our decimal here, this 1 here is occupying the tenths place. This 9 is occupying the hundredths place. This 8 here is occupying the thousandths place. The 2 here is occupying the 10,000ths place. and the 0 here is occupying the 100,000th place. Okay, so there's two ways of looking at this number. We can take a look at it in terms of the number places that these numbers are occupying, or we can also take a look at this number in terms of the amount of significant figures there are in this relatively large number right here. And so what we're going to do now is we're going to learn how to round a number like this to a given number of significant figures. For example, what if I asked you to round this number to 6 significant figures? Well, right now it has 13, and if you wanted to round it to only 6 significant figures, you would be rounding it to this place right here, right? You would have to round it to only 6 significant figures. All right, so let's go ahead and do that. Let's go ahead and take a look at how we can take a number like this and round it to a given place or a given number of significant figures. So what we're looking at are our rounding rules for chemistry. It says that when rounding answers to your calculations in chemistry, follow the rules below. And these rules are essentially the same rules for rounding you have learned in a math class, with one exception, that being in rule number 3, which we'll take a look at here momentarily. However, in rule number 1, it says if the digit to be dropped is greater than 5, then add 1 to the last digit to be retained and drop all digits farther to the right. So for example, let's suppose we have this number right here, 3.677, and we want to round this off to only 3 significant figures. So the first significant figure, if we start on the left, is right here, the second one is right here, and the third one is right here. So what we're going to have to do is we're going to have to look one past our third significant figure, and we see that it is a 7. And so very similar to the rounding rules that you learned in elementary school, this 7 is going to round this 7 up to an 8, and we'll end up with 3.68 if we're asked to round this to 3 significant figures. It says right here that if we want to round this same number to 2 significant figures, we'll start on the left. Here's our first significant figure. Here's our second. And this 7 here is going to round this 6 up to a 7 for 2 significant figures, 3.7. If we take a look at rule number 2, it says if the digit to be dropped is less than 5, then simply drop it without adding any number to the last digit. So if we take a look right here, we have 6.632, and we want to round this to 3 significant figures. So we'll start counting these significant figures from the left. Here's our first one, here is our second one, and here is our third one. We're going to look one past our third one. We see that it is a 2. And the rule here says that if it's less than 5, then simply drop it without adding anything. So 6.632 rounded to 3 sig figs will be 6.63. If we take a look at this example right here, 6.632 rounded off to 2 significant figures will end up being 6.6. Let's take a look. Here's our first sig fig, here's our second sig fig. This 3 is not going to round this 6 up, so we just leave it at 6.6. But let's take a look at rule number 3. It says if the digit to be dropped is exactly 5, then A. If the digit to be retained is even, then just drop the 5. So for example, what if we have this number right here, 6.65, and we're asked to round this to 2 sig figs? Well, if we take a look, here's our first sig fig, here's our second. We're going to look one past our second sig fig, and we have a 5 here. So our rule here is this: if the number next to our 5 or to the left of our 5 is an even number, then we leave it alone. We leave it alone. We do not round this up, which is kind of contrary to what you've learned in an elementary math class as far as rounding. But if you have a 5 that you're trying to drop, and the number next to it is an even number, then we just go ahead and leave that alone. We don't change it at all. So 6.6 will be the correct answer here. However, it says if the digit to be retained is odd, then add 1 to it. So for example, what if we have 3.4675 and we want to round this to 4 sig figs? So let's go ahead and count. We have 1, 2, 3, 4 sig figs. We're going to look one past our 4th sig fig, and it's a 5. However, the number next to our 5 or to the left of our 5 is an even number. In this instant here, we're going to go ahead and round this up to an 8, and our final answer to 4 sig figs will be 6.468. All right, and so it says remember that 0 is an even number. So if we have 3.05 and we want to round this to just 2 sig figs, We'll look at 1, 2 sig figs here. This 5 here is not going to round this 0 up, since 0 counts as an even number. And so if we wanted to round this to just 2 sig figs, our final answer will be 3.0. So let's go ahead and apply these rules to several different example problems, and then you're going to try some example problems on your own at the end of this video. Alright, so it says, using the rules of rounding, round the following numbers to the indicated significant figure or decimal place. So if we take a look, we have some numbers here, and what we have to do is round them to the indicated significant figure or decimal place. So let's take a look right here. It says to round the following numbers to 1 sig fig. So if we take a look, right now this has 4 sig figs. We have to round this to just 1 sig fig. So if we take a look, we'll start on the left when we count our sig figs. Here's our first sig fig. We're going to look 1 past this, and this 6 here is going to round this 2 up to a 3. And so it looks like we will end up with 3 grams if we just want to round this number to 1 sig fig. If we take a look right here, here is our first sig fig. We're going to look 1 past this, and this is a 4. This 4 is not going to round this 1 up. In fact, what will end up happening is that our final answer here is going to be 10,000 kilometers for 1 sig fig. We've rounded 14,568 to just 1 sig fig. 10,000 with no decimal only has 1 sig fig. Make sure you keep your decimal places here, or your placeholders here. 1 would be the incorrect answer here, even though it does have 1 significant figure. 10,000 is a lot closer to 14,000 than 1. Let's take a look right here. It says, round the following numbers to 2 sig figs. So this time we have 1, 2 sig figs. We're going to look 1 past our second sig fig, and it's a 4. This 4 is not going to round this 2 up to a 3, so we'll just end up with 22 liters if we wanted to round this to 2 sig figs. And here we have some scientific notation. That is not a big deal. When we're rounding scientific notation, all we're going to do is look at our mantissa. This right here is called a mantissa. And so if we take a look, here's our first sig fig, here is our second sig fig. We're going to look 1 past this, and it's a 5. Remember rule number 3 in our rules. If this here is a 5, if the number to be dropped next to our indicated number of significant figures is a 5, then we look to the left, and if it is an odd number, then we're going to raise this up. So it looks like this is going to end up being 2.8 times 10 to the 8th kilometers. Let's take a look at this one. We want to round the following to 3 sig figs. So if we take a look, we have 1,324 grams. Here is our first, second, and third sig fig. We'll look 1 past our third sig fig to the right. It's a 4. This 4 is not going to round this 2 up, so it looks like we'll end up with 1,320 grams as we round this to just 3 sig figs. If we take a look right here, this is a tricky one. Right now, as this looks, 14 million, we have only 2 sig figs, but we want to round this to 3 sig figs. So how can we do this? Well, if you just go ahead and write 140 milligrams, this would be incorrect. Yeah, there's actually, this, if you write it like this, there's 3 sig figs. However, 140 is far away, is not even close to 14 million. So this would be incorrect. What we'd have to do is convert this to scientific notation. 1.40 times 10 to the 7th milligrams. We have 3 sig figs in our number now. We've converted it to scientific notation. Let's take a look right here. It says to round the following to 4 sig figs. So we have 1, 2, 3, 4. And you guessed it, this 8 here is going to raise this 1 up to a 2 for 7.252 liters. And we have 4 sig figs. If we take a look right here, we have 1, 2, 3, 4. And we're going to look 1 past our 4th significant figure, and it's a 5. And so our rule states, if it is a 5 that we're trying to drop, then we have to take a look at the number to the left of it. And if it's an even number, we're not going to raise it. So this just ends up being 375.6 kilograms. Let's take a look right here. Round the following numbers to the 10th place. So where is the 10th place? Here is the 10th place right here. And so what we have to do is we have to look 1 past our 10th place, and we'll see that it is a 6. Our 6 here is going to raise this 1 up to a 2 for 2.2 times 10 to the 5th liters. Let's take a look at this one. We want to round this number to the 10th place. Here's the 10th place. This 4 is not going to round this 7 up, so we just end up with 54.7 kilometers. What about right here? We want to round the following numbers to the hundredths place. Where's the hundredths place? That is 2 places to the right of the decimal. And so if we look 1 place past the place that we're trying to round to, we'll see it's a 0. This 0 is not going to round this 3 up, and so we'll just end up with 0.03 kilograms. And you might be wondering if you need to put this 0 here. Yes, in chemistry, technically, this 0 always needs to be added in our ones place. What about right here? We want to round this to the hundredths place, so here we go. Hundredths place is right here. We're going to look 1 past, and it is a 5. And so if it is a 5, remember our rule. We have to take a look at the number to the left of our 5, and it is an odd number. So if it's an odd number, we're going to go ahead and raise this up to a 6. So 7.56 meters will be our correct answer to this one right here. Let's take a look at a few more. In these examples right here, it says using the rules of rounding, round the following numbers below to the indicated significant figure or decimal place. So same thing here, except we're dealing with numbers smaller than 1. Let's take a look at this first example. It says to round this to just 1 sig fig. So if we start with our first significant figure on the left, that would be right here. Remember, leading zeros don't count, so our first sig fig is right here. We're going to look 1 past this, and it is a 0. This 0 is not going to round this 2 up, so just 0.2 liters rounded to 1 sig fig. If we take a look right here, we want to round this number to just 1 sig fig. So where is our very first sig fig as we start from the left and move left to right? It is right here. Leading zeros don't count. We're going to look 1 past our first sig fig, and it's a 5. And so the rule is, if this is a 5, we look next door to the left. And if it's an even number, we are not going to round this up. So just 0.004 kilometers will be our correct answer if we want to round this to just 1 sig fig. What about right here? It says round the following to 2 sig figs. So we'll start from our left, work our way left to right, and here is our first and here is our second sig fig. We'll look 1 past it, and it is a 5. What's the rule? If this is a 5, we look next door to the left. This is an even number, so we are not going to raise this up. And so 0.086 milligrams, 0.086 milligrams will be our correct answer. Let's take a look right here. Our very first sig fig as we move from left to right is the 3, and then we have a 0 right here. So if we look 1 past our second sig fig, it is a 6. This 6 is going to raise this 0 up, so 0.031 milliliters will be our correct answer. What about right here? We have to round the following numbers to just 3 sig figs. So right now we have 1, 2, 3 sig figs, and our fourth sig fig is right here. So our 7 is going to round this 0 up to a 1 for 2.01 times 10 to the negative third kiloliters is our final answer. Let's take a look right here. Our very first sig fig as we move from left to right is right here. This trailing 0 does not count. So we have 1, we have 2, we have 3 sig figs right here. We're going to look 1 past our third sig fig, and it is a 3. This 3 is not going to raise this 0 up, so just 0.420 grams will be our correct answer. What about right here? Round the following numbers to the 10th place. The 10th place is right here. We're going to look 1 past our 10th place, and it is a 5. So the rule states that if it is a 5, we have to look at the number to the left. And if it's even, we are not going to raise this up. So just 0.4 grams will be our correct answer. What about right here? We want to round to the 10th place. The 10th place is right here. We're going to look 1 past our 10th place, and it is an 8. If it's higher than 5, we're going to go ahead and round this up. We're going to round this up to a 0, and this becomes a 4 for 4.0 times 10 to the negative fifth kilometers. Let's take a look at this one. We want to round this to the hundredths place. The hundredths place is right here. We take a look next door and we see it's a 5. So the rule states if this is a 5, we're going to look to the left, and if it's an odd number, we're going to go ahead and increase this. We're going to raise it by 1 for 5.68 times 10 to the negative fifth kiloliters. What about right here? The hundredths place is right here. We'll look one past our hundredths place. It's a 7. So that 7 is going to raise this 1 up to a 2 for 0.02 milligrams. What about right here? We want to round the following numbers to the thousandths place. Where's the thousandths place? Here's the tenths, the hundredths, and here's the thousandths place. So what we have to do is we have to look one past our thousandths place, and it is a 7. This 7 is going to raise this 6 up to a 7 for 1.037 times 10 to the negative third grams. What about right here? Where is our thousandths place? Here's the tenths, here's the hundredths, here's the thousandths place. We'll look one past our thousandths place, and it is a 6. This 6 is going to round this 4 up to a 5 for 0.005 kilometers. So that's how we're going to go ahead and round. Let's take a look at some that you can try on your own. So what I recommend you do is pause the video at this point and spend 5 or 10 minutes trying these out on your own. See if you can get the correct answers. Go ahead and round 43 million to just 1 sig fig. Go ahead and round this number to 2 sig figs. Go ahead and round this number to 4 sig figs, etc., etc. And I'm going to give you guys the answers right about now. So how did you do? Did you get them all correct? If so, then you're pretty good at rounding, and that is how you're going to round in chemistry all year long. So that is rounding in a nutshell, and I really hope you guys found this helpful.